Muted.
Good evening, everyone. Welcome to today's session. So yesterday we discussed, we started about the basics of generics, right? Today we'll continue the same topic. We'll try to cover as much as possible and to cover whatever is there in generics, okay? Like generic methods, generic constructors, and how we can use generics in uh, object hierarchy, okay? Generic object hierarchies and all, okay? So we'll start with generic methods. So whenever we create a generic class, we will specify type information to the generic class, right? So any method within that particular generic class, for example, say a, t, okay. So I have a method, okay. So this method is automatically a generic method. This method is automatically a generic method with respect to the generic type that is specified in the class, because the method can use this particular type. Okay, the method can use this particular type. That is why with respect to this particular type that we specified that we have specified for class A, this will become generic. Okay. Apart from this, we can have methods, generic methods within generic class, which can take more than or one or more generic type. Okay, one or more generic type. I hope all of you can hear me, and you can hear. I'm assuming that I'm audible, and then you are all able to see my screen. So if at all any issue is there, please let me know. Okay. So it is also possible to create a generic method within a generic class that takes one or more type parameters. Okay, one or more type parameters. Yeah. Also, we can create generic methods within non-generic class. Okay, we can create generic method within a non-generic class. Okay, so let us see a few examples, and then we will try to explain how. We'll try to understand with the couple of examples. Okay. Okay. So here this is a method. I mean, this is a class which is non-generic. Okay. In previous class, we have seen a couple of methods within our. Give me a second. Bounded class. Okay. So I was just trying to get an example of generic method. That is fine. So here we have a non-generic class. Okay, this class is a non-generic class. So that we can find out just by looking at the name of the class. Okay, we are not passing any type parameter. We are not passing any type parameter to this particular class. Because of that, this is a non-generic class. Okay, non-generic class. This is a non-generic class. Okay, so in this we have specified a method, or we have declared a method which is generic. This is a method which is generic. Okay, is present in is a method which is generic. So how do we come to know that that's a generic method? This is the parameter, generic parameter. Okay, that we are passing here. here we are passing those generic types. Okay, so here if you see, important things to note here are while declaring a generic method, first we specify the parameters. Type parameters are specified first. Before type parameters are specified before the return type of the method. Return type of the method. Okay, this is our return type, and this is the type parameters that a particular method takes. Type parameters of the parameters that a generic method takes. Okay, these are the type parameters. Type parameters of what? Type parameters of the parameters that are passed to the parameters of a method. Okay. So we specify the type parameters of a parameters of a method first, then the return type, and then we specify the method name and we pass the parameters. So if you see here, it takes two parameters, one parameter of type T, okay, and another parameter V, which extends T, which extends T. Okay. So here, this is important because we have to here what is the functionality of this particular function is our method is we will pass one value and an array, and we will verify whether this particular value exists in this array. Okay, it can be a I mean, it can be anything. For example, if I pass integer, okay, this should be of type either integer or subclasses of integer. Okay, that is why we have specified this bound. Okay, we have specified this bound type here. Okay, so let us see how this works. So here, what are we doing? We will we'll pass an array. In that array, we iterate through that particular array. If whatever the value that we have passed here that is found, we will return true. Otherwise, we will return false. If this method returns true, it means the past, whatever the value we are checking within an array exists, or if it is true, if it is false, it does not exist. Okay, does not exist. So let us see an example and to see how we can call those methods. Okay, a few important things are just like this. So the syntax would be syntax for declaring generic method is we have access type, and then I have that one here only, so let us not waste the time. So we will try to see the syntax in this slide. So I have mentioned the syntax here itself. Okay, how to declare the generic method. Okay, we specify the access specifier and then type parameters. Okay, this is what I have mentioned, like parameters, method, we can say like method parameter types. Method parameter types. Okay, as you can see, it is mentioned, it is specified before the return type of the method. Okay, here we specify the name of the function and then parameter list. But this parameter list should be the type of this parameter list should match the type of parameter type of the parameters or parameter types that we have specified before the return type. Okay. So let us see this example. So what are we doing here? So we have to have two parameters, one some value and another array of same value or subclass of that one. Okay. So we have specified one particular integer here and integer array, and then we are passing that integer array here and some value here. Okay. If it is present, we are printing 2 is present in that particular array. Okay. Similarly, we will check whether that particular one will pass and whether that exists in some other. If it is not existing, we will say it doesn't exist. Okay, that is with respect to numbers, and we can see. We have created one more array with strings, the same logic. Okay, even we can create any other type. Okay, in the sense like we have passed integer array here, string here. You can pass any other data type. Okay, you can create, for example, what you can do is you can create generic method generic method array, right? Okay, this should be of. Okay. Okay, you can pass this also. You can pass it. Okay. This is an array of generic methods only, generic method classes only. Okay. This also we can pass it to these methods. Okay. Like this. Okay. Let us create methods with a few objects, and then we pass those objects to this thing. Okay. Otherwise, we will not be able to figure out. Method GC is equal to generic method. Okay. Okay, so what we have done is we have taken three generic types. One is the integer, another one is string, and one more is generic method itself. Okay, let us try to run this program and see whether it works or not. Okay, okay. So here, what are we trying to do? So here, what are we trying to do? Initially, we pass 2, and within an integer array, we are trying to see whether that is present or not. So it is present. Okay. 7, that is not present because only 5, 1, 2, 3, 4, 5 are there. Okay. With the strings also, 1 is present, 10 is not present because for 1 to 5 are there. Here you can see. Okay. And then GC, first we pass this particular object. that is this object, right? So that should be present because that is there here in this array. But here what are we doing? We are trying to create a new array or new object, generic method object, which is not present in generic method array. Okay, that is why it says this particular generic method does not exist. Okay, this particular new object does not exist. Okay, that's why it says this particular new object does not exist. Okay, this is how we create a generic method within non-generic class. Okay, this is a non-generic class, and we can create generic method. And in previous class, I don't remember which class I created that one. Let's see. Yeah, here we have used within generic class. Within generic class, we have used one generic method, which takes, as we just mentioned, any method within a particular generic class. This is a generic class. Any method within a particular generic class, it will become automatically. It will become a generic method with respect to this particular object, whatever the type that we are passing. Okay, so because we can use that particular object in your method, that is your type parameter. Type parameter, you can use it within a method. It automatically becomes a generic method with respect to the type parameter that is passed to your class itself. Okay, that is passed to your class itself. Okay, that is why all the methods, whichever you see inside your generic methods, they are automatically generic. I mean, generic class, they are automatically generic methods. Okay. Okay. So let's move on to the next topic. That is. So the same, whatever I have just mentioned, the same thing I have put it in this slides. Okay. So as we have seen, how are we calling this generic method? So while calling this generic method, right? So we have declared generic method like this. But in case of creating objects, we have specified for reference variables, we have specified generic types, right? Here we are not specifying anything. If you see here, these are how are we calling this method? We are calling these methods just like any other method, non-generic method that we call that. It is similar to how we call non-generic methods. Same way we are calling generic methods as well. Here we are not specifying like here we are not specifying like, okay, we have to specify integer and then another integer like that. We haven't specified like that, or before that also like this. Here also we haven't specified anything. Integer, integer like this. Okay, nothing. We have not specified. We are just calling these methods as we call non-generic methods. Okay, as we call non-generic methods. Similar to how we call non-generic methods, same way we call these methods also. And one more important thing that we need to remember, notice here is similar to how we can have both static as well as non-static methods in non-generic classes. We can have both static and non-static generic methods. Okay, we can have static as well as non-static generic methods. That too, inside generic classes as well as non-generic classes. Okay, both inside the generic as well as non-generic classes, we can have static as well as non-static methods. Also static members and non-static members. We will see what are the restrictions when we use static with those generics. Okay. Okay. So this is how we called the method without I mean like normal methods. Okay. How we call normal methods. So let's go move on to the generic constructors. So like whenever we have the generic class, right, we must have at least one constructor that takes a generic type that we pass to an generic class. Okay, that we pass to a generic class. So apart from that, we know that a generic class will have generic constructor, but apart from that, we can create generic constructors for a non-generic class as well. We can have generic constructors for non-generic classes, similar to how we had we could create generic method within a non-generic class. Okay, how we could create a generic method within non-generic class? We can create generic constructor within non-generic class. That means non-generic class can have generic objects. Okay. Then similar to how we call generic methods, we call constructors, generic constructors, without specifying any type parameters to it. We just pass parameter to while creating an object. Okay, it is similar to how we create objects for normal non-generic classes. Okay, we don't specify any generic types there. So syntax for creating a generic constructor is you specify, similar to how we specify first we specify the type parameters, right, before return type for methods. Similar to that one, we specify the type parameter list first, and then the constructor name, and then type parameter object. Okay, type parameter object. It should have a type parameter object. Okay. So let us see an example of that. And this is for generic method. This is for generic constructor. Okay. So we have a non-generic. If you notice, this is a non-generic class, right? We haven't passed any type parameter to this particular class. So that is why we don't have any type parameter information passed to this particular class, and we have a constructor which takes a type parameter here. Okay. So similar to how we specified type parameter list, before return type, we have specified the type of the parameter that is passed to this particular constructor. We are not specifying, if you notice, we are not specifying the type information here itself. Say for example, this particular syntax is not valid. Generic constructor C extends number. Okay, this one is not possible because we cannot specify here within the parameter list and then create an object of that particular parameter. Okay, create an object of that particular parameter. That is why we specify outside and then use that type argument, use the type as argument to this constructor and create with an object of that particular type parameter. Okay, I hope everyone is getting what I'm trying to explain. Okay, that is what I'm assuming. If you have any confusions or if you need any clarification, please let me know. We will revisit that. Okay, so here is a method which is a normal method, and here we have another. This is a generic method. Okay, let me put this way. This is our generic constructor. This is generic method. This is non-generic class, and this is non-generic method. Okay, so within non-generic class, we have both generic method and generic constructor. Okay, so that is also possible. So let us see this test. Okay, so we have created the generic constructor object, and note that generic constructor object, and note that we haven't specified. We have not specified any type information here while creating the object. We have not specified any type information while creating the object. Okay. So here, so what is the upper bound? What are the things that we can pass only to this object? See the definition of this constructor. See the definition of this constructor, and tell me what are all the objects that we can. What are all the types? What are all the objects that we can pass to this particular constructor? Let me write that definition here. So what are all the objects that I can pass here? Yes, correct, Karika. Integer, float, and double. Yeah, excuse me. Is this possible? What about characters? Yeah, Karika, what about character? Can we pass character to this?
Character, char is primitive wise.
Okay. What about
character? I think it is, if it is an object,
only numbers are possible. Okay. So only anything which is which extends number, right? That we can pass. Character does not extend number. Okay, character type. So that is why we cannot pass character. Okay. So only valid values are any numeric types. Okay, any numeric types is your float, double, byte, short, int, and long. Okay, only these things are possible. All other things it won't allow. Any other object it won't allow. Okay. So let us comment this particular part. So if you see here, we are calling this constructor just like any other normal constructor. like any other normal constructor. Okay, so we are not passing any type information. Who takes care of the type information? Compiler will take care of that. Java itself will take care of that type information. Okay, so as soon as we specify some other type, it will not allow. Can we have, if we change this definition, if we change this definition of okay, if we change this to just T, can we pass string here and characters here? Can we pass? Say for example, I have one more class. Okay, that takes public. I just specified T. Okay, constructor 1. Okay, T obj, and then I will return T obj. Okay, so what I will do? Okay, we cannot pass this T here. Okay, why we cannot pass T here? Why we cannot pass T here? Can anyone tell me why we cannot pass T here? We cannot use T here. Can anyone tell me why we cannot use T here? Do you know anything about scopes? Okay, seems like no one is showing interest in listening, just attending the class. Okay, so this scope is restricted only to this particular constructor, right? So we cannot use this T outside of constructor. Okay. No, we have used Kaita. Yeah, she is telling. Yeah, yeah, correct here. So, yeah, you can explain it to us here. Okay, so only simple thing is, yeah, let me explain only. The simple thing is, we have declared, okay, so we have declared this T, that is the type parameter. Type parameter for this constructor. Okay, this type parameter is valid only within the constructor. Okay, within the constructor only we can use this type parameter. Okay, other outside we cannot use it. That is why if we try to declare an object of T, it is not. It is showing compilation error. Okay, so we can use only within whatever we want to do. We can use. I mean, we can do that with T within constructor. Okay. Okay. So let us we cannot assign anything. Okay, so let us have this one. Okay, let us have this and try to create objects of this particular constructor one. Okay, now this should be possible. And the constructor gc string is equal to new. Sorry. One of string. This should be possible. So we can pass any type for that matter. Okay. So say for example this one. Okay, this is also possible. So for that matter, you can pass constructor 1 easy to new generic constructor of generic constructor. Hope you can see this one, okay? Okay, it has to be some value. It has to use some value. Okay. So see the thing here. Here, this is accepting. This needs a generic value. Okay, some value. This constructor has is of generic type. This constructor is also of generic type. But this constructor accepts only. This is generic constructor. It takes only integers. Okay. This is a generic constructor which is of type, which accepts type, any type. Okay, any type, string, integer, or whatever it is. It takes a generic constructor type also. But here we have to specify only numbers. In this case, we have to specify only numbers. Okay, that is because we have specified, we have used a bound type for this particular constructor. Okay, the restriction is we can only pass number types. Okay. Okay, let us move on to the next topic. Okay, so similar, not only methods, not only constructors, not only classes, you can have generic interfaces also. So we have specified the type parameter list before using them inside the identifier, before using them inside the method or constructor. Okay, that is what we have, this we should remember. Okay, for methods and constructors, we have to specify the type parameter before you name them and use them inside your constructor as arguments or methods. Okay, so generic, we can have generic interfaces as well. It is defined similar to how we define or declare for classes. Say for example, here you have access specifier and then interface keyword. Okay, then identifier, name of the interface, name of interface, and then you specify the type parameter list. Type parameter list. Okay, so can anyone tell me, like, can a non-generic type a non-generic class implement a generic interface? Can a non-generic class implement a generic interface? Is it possible? Let us see. Okay. So let us see this example and then we will discuss about that. Okay, here this is the interface. We have specified the type information here. Okay, this looks a little scary. Okay, he is telling we can non-generic class can implement generic interface. Okay, let us try to do that one. So before that, let us finish this particular topic. Okay, that is generic. Okay, so let us see this within this topic. Let us see whether that is possible or not. Okay. Okay, so here what are we trying to do with this min-max interface? So we have two method declarations. One is min and another one is max. Okay. So what it does is minimum number. If we pass an array, it returns minimum number and maximum number within an array. Okay, maximum number within an array. Okay, here we are passing a type. Here we are passing a type which extends comparable. Okay, comparable is an interface defined in your java.lang package. Okay, any object or any class that implements comparable can be ordered. Okay, they can be ordered in, or two objects can be compared. Okay, two objects can be compared using. We will see about this comparable interface in when we discuss about Java. When we discuss about Java built-in packages. Okay, like java.lang, java.util, and java.io package. Okay, during those discussions, we will discuss more about this one. Okay, so any two objects, say for example, you have one particular class that implements comparable. Okay, so there is one particular method called compare to. You should implement that particular method compare to. So how do you implement that compare to method? That compare to method should be implemented in such a way that if two objects of same type, can be compared. Two objects of same type can be compared. So how does the compare to work? Compare to method works. We have discussed this method in when we were discussing about compare to method, when we were discussing about annotations. Right? So how does this work? If it compares an object dot compare to of another object. Okay, this one, the value of this one will be compared with the value of this one. Okay, if it is this is the number is positive, 1 is greater than 2. Okay, object 1 is object 1, object 2. Okay, object 1 is greater than object 2. Okay, if the result is 0, both objects are same. Okay, if the result is less, this object is less than this one, that means this is if the result is negative, this object is less than this one. Okay, that is how the comparative function works. Okay, that is how, if at all you are trying to override comparative method, you have to take care of these things. It should return positive value when you are comparing an invoking object with another object. Okay, positive where when invoking object is greater than the the object to which you are comparing is greater than, it will result positive number. If both the objects, the one which is invoking and the object which is getting compared, right, both are equal, then it should return 0. And if the invoking object is less than the compared object. Okay, so here, say for example, you have an object dot compare to another object. Yeah, Kavita is telling -1, 0 and 1. It need not have to be -1, 0 and 1. It can be, yeah, but what we can generalize is positive, 0 and negative numbers. Okay, 0 means it is equal. Both objects are equal. Okay, here this is the object which is invoking compare to method on another object. This is the object to which we are comparing this object. This is invoking object. This is the object which we are comparing with. Yes, correct. Current object is, that is what the object on which you are invoking the comparative method. Current object is same thing, like whatever the object that you are invoking. Okay, if the to make things not to confuse, I'm just extending this with this example. Okay, so if this object is greater than this object, positive number will result. Okay, it could be 1, it could be any other positive number, like this saw in case of this one, right? What is that? In case of ordinals, which topic did we discuss about ordinals? Enumerations. Okay, in case of enumerations we saw, right? It compares the ordinals of each enumeration constants or enumeration objects within an enumeration, right? So it may not have to be 1. Okay, it can be more than 1 based on how they have implemented compared to. Okay, based on the requirement of that particular object comparison. That's it. Okay, it can be either positive, 0 or negative. If this is greater than this object, it is positive. If both are same, it is negative. If this is greater than this object, it is negative. Both are same means it is 0. Sorry. Okay, so the same comparative method we will use it to determine the minimum and maximum of a number. Okay, so let us see how we have implemented that logic in min-max implementation. Okay, one more important thing is, so why have we mentioned this particular part? So we have T. Okay, T extends comparable. Can anyone tell me tell why we have used this one, this T here? Can anyone tell me? Can anyone think and tell me? Because comparable is in java.lang. Okay, this is built in generic interface. This is built-in generic interface. That is why we have to specify a type parameter for this particular interface. Okay, that is why how we have specified here. We have specified this is the type information that we are passing to this particular interface, right? That extends comparable. Okay, we cannot just type T extends comparable. This is possible, but since this is also possible, but since comparable is also a generic type, we have to specify it also takes a generic parameter. Okay, that is why we have specified this parameter. This is the type parameter for comparable interface. This is the type parameter for comparable interface. This T is type parameter for min-max interface. Okay, got it? So this is type information for comparable interface. This one is type information for min-max interface. Okay, so what are the, so it is also type, what do you say? So this one is the bounded type. Okay, we have specified upper bound as comparable. Any object which can be compared, we can pass that to min-max. Okay, okay. Let us see how we have implemented that one. So here we have IMPL. Here we have IMPL class, and then which this is not good. So here we have IMPL class. So see how we have declared that class. Okay, this exactly matches. This exactly matches the interface declaration. Okay, this exactly matches the interface declaration, and this implements min-max. Here we have not specified how we declared our interface. Okay, this is how we have declared our interface. That is how we have declared the type parameter for the interface. But here, when using in a class that implements that interface, we have not declared like that. Okay, because any class that implements an interface, any class that implements a generic interface any class that implements a generic interface must also be a generic class, because whatever the parameter type that you have specified, while declaring an interface, the same thing should go to this particular class. Okay. So once that is done, once this particular type parameter definition is done here,
Muted. Muted.
yeah, sorry, I think I pressed the wrong button here. So while selecting pen, okay. So let us continue. So whatever the definition, right? Here we have specified the type parameter, right? Type parameter. Okay. So whatever the class that implements generic interface, that must also be a generic class. Okay. So when we are declaring that particular class, we specify the type information that was specified in the interface declaration. Okay. Once this declaration is done, there is no need for us to repeat the same declaration here. So we will just pass this P as argument to this particular interface. That's it. Okay, we need not have to redeclare the same thing. The context is already defined, so we will not bother to define the same thing, same type parameter information here. Okay, and if we try to do that, it will result in compile time error. Okay. Okay. So that's how we defined this particular class, and so whenever you declare a generic class, it should have a constructor which takes a generic object. Okay. So here we have declared one generic array. Constructor is taking the generic array. Here we have overridden this particular method, these two methods. What is it doing? It is using compare to. Based on the value it returns, we will see which one is greater, and then we will get the minimum value and maximum value. Okay. Let us see how we have implemented that, or how we tested it, how we can test it. Okay, I've taken three different types. One is integer, another one is character, third one is string. Okay, for that matter, how we tested in another example, right? We have just passed to an array, we just passed generic class object itself. But one important thing we need to remember is if you want to pass, okay, so let us complete this one and we will try to do try to pass the generic class itself. Okay, generic class itself and see what exactly happens. Okay, so here 1 is our minimum number and 5 is our maximum number, and here we have to find out which character is minimum and which character is maximum. Okay, and here we have to see which one is which string is less and which string is more. Okay, so let us run this program and see what is the result, what it results. Okay, so here obviously we got this one. So in with respect to characters, uppercase characters comes before lowercase characters. Okay, that is why this is the minimum one, because this is uppercase and this is the maximum one, A to B. So B is and A to A to Z and A to Z, small z. Okay, so uppercase letters come first and lowercase letters come next. So since B comes after your A to other characters, this is your maximum number and this is your minimum character. Okay, and in case of your strings, character by character they are compared, and then which is less, C# is less and Python is more. That's it. Okay, so let us try to implement this particular logic. Okay, so let us try to create. No need to create the objects, we already have it. Not this one. Methods. Okay. Can anyone tell me whether it is possible or not? Can we try to pass this to min-max implementation, and will it allow us to do it? Can anyone just see and tell me? Can anyone tell me? Just think whether it is possible or not. You have to think like how this particular is declared, interface is declared. Based on that one, whatever the explanation I gave, right? Based on that one, you can think and tell me. So why is it showing error? Why is it showing error? Can anyone tell me why is it showing error? And how to correct this error? Theta is telling GC. Okay, we can put the GC also, that is not a problem. Okay, still it is showing error. Why? There is a specific reason for that error. Whether you use this one or not, there is a specific reason. You have to think about that reason. Tell me why it is showing this error and how to correct that error. That is also you have to think. Okay. So just look at the definition here. So what are we passing as type parameter? Does this implement comparable interface? No, right? So how to correct this error? This will show error. No, it has to implement, right? Okay. So now, are you seeing what exactly is happening? So any class that implements a generic interface, right? That also must be a generic type. Okay. That also must be a generic type. Okay. So it is asking us to implement compare to twice. Okay. Okay. So we already have, but it will again show if we try to modify this, right? It will show problem with these things. This particular we will get error because of this particular statement. Okay, because of this statement. So because we have T as object, okay, we are passing. This is a double object. Okay, this is a double object, but we are passing T here. T can be any. Yeah, correct. With implements only. So T can be any object. Okay, T can be any object, but all object does not define. We are telling like OBJ double value, right? So all objects can't. All objects don't have a double value method defined for them. Okay, that is why if you pass string, right? String will not have a double value method inside the class. Okay, that is why this will give an error. Okay, again this is showing error. Let us not worry about those things. You try why all those things are happening, and you try to do R&D on these things. Okay, this is just that is how you can avoid that error, correct that error in fact. Okay. Okay. So let us comment this part. This is not needed. Okay, let us move on to the next topic. 35. Yeah. So what do we have next? So syntax for generic interface, we know type parameter, interface, identifier, type parameter list, but while declaring, you have to specify this one. Okay. Some important things. One important thing that we need to remember is if a class implements a generic interface, that class must also be a generic class. Okay, that is what is very, very important. You cannot implement a generic interface on a non-generic class, or a non-generic class cannot implement a generic interface. At least till 7, that is what I have, 7 version, that is not allowed, but I'm not sure about 8. Okay, you can verify and let me know in our next session. Okay. Okay, let us move on to the next topic. So legacy code. Okay, so legacy code is, what is legacy code? Anything we generics, yesterday when we were discussing about generics, right? So we just mentioned saying like generics were introduced from JDK 5. Okay, generics were introduced from JDK 5, but before JDK 5 came, there was lot many applications which are written using JDK up to JDK 4. Okay, so before JDK 5, there was no concept of generics. Okay, so when JDK 5 was introduced, generics were introduced. Okay, so if you want to move or if you want to migrate the code from JDK 4 to JDK 5, okay, so whatever the code that you have in JDK 4, they are not aware of generics at all. Okay, whatever the code that you have in JDK 4, they are not at all aware of what are generics at all. But if you want to move non-generic code to generic code, that compatibility should be there, right? That compatibility should be there. So that is what is achieved. That JDK 5 implementation of JDK 5 took care of that migration part as well. Migration. So that the migration transition from JDK 4 to JDK 5 is easier. How they took care of that one? If you have a generic class, okay, if you have a generic class, you can get away with that particular generic class without passing type parameter to that class. Okay, say for example, you have a t. Okay, so you can create an object. Okay, so let us say this is, I am passing an integer. Okay, a is equal to a from 10. Okay, so this is not mandatory. Okay, you can just create a is equal to a of 10. No need to use these things. Okay, this will become what is known as raw type. Okay, without any type argument. We are not passing any type argument here, like integer, float, whatever it is, whatever the data type. Without any type argument, that is called as your raw type. Okay, that is what enabled, that is what made transition from JDK 4 code to JDK 5 easier. Okay, but there are some few more keywords were introduced with the JDK 5. Those were also, I mean, kind of like we manually had to take care of those kinds of those keywords. Say for example, assert. Okay, I think from JDK 4 or so, assert became a keyword in Java. Before that, there was no keyword by name assert. Okay, people might have used assert as variable name itself in JD before this particular keyword was introduced. Okay, we should, in such cases, right, we should manually take care of those kinds of words when we migrate from one particular version to another particular version. Okay, so the raw types allowed the transition from JDK lesser than 5 to JDK 5 and plus. Okay, made the transition easier. Okay, made the transition easier. So we have okay. So let's move on to the next topic. So we have discussed about inheritance. Okay, let us see how we can use generics in terms of inheritance. How we can use inheritance. A generic class can be a superclass of a subclass. Okay, a generic class can be a superclass of a subclass. So whenever you are using a superclass, this subclass can be a non-generic type also. The subclass can be a non-generic type also. But if superclass is there, whenever we discuss, when we were discussing about inheritance, we mentioned one important thing. Okay, we mentioned one very important thing with respect to inheritance. That is, the parent should exist. Parent should exist before a child is created. Parent should be created before a child is created. That means superclass object should be created before subclass objects are created. Subclass objects are created. Okay. So when you are using generics, that matters. Okay. In what way? Superclass must be, so say for example, you have a subclass and so a generic type and B extends A. Okay. So whatever it is, the type information, right? Whatever the type parameter that a superclass takes, okay, that has to be passed to superclass. There is no other way. There is no other workaround for that. You have to pass that type information to superclass. Then only you will be able to create superclass object. Okay. Only after your superclass object is created, your subclass object will be created. Okay. Only after your superclass object is created, subclass object will be created. Okay. So that is why if you have a subclass, generic subclass, you must pass the type information to superclass in order to create superclass object before your subclass objects are created. That is why the type information has to be passed from, that is it has to be passed from subclasses to superclass. Okay, that is a must. It is a must. Okay, it is a must. So let us see an example. Okay, so that will make things easier. Let us close all these things. So here I have taken non-generic class, superclass, and the generic subclass. Okay, I haven't mentioned generic class, generic subclass. So while discussing about generic classes, right, that is raw types. I'm discussing about raw types. I forgot one thing to mention. Okay, so that is when we don't pass type argument while creating the object, that becomes a raw type, right? It becomes a raw type. So what is the disadvantage of using the raw type? Generics provides type safety, right? This main thing itself is lost when you don't specify type argument while creating the object. Okay, what does that result? Yesterday we saw an important example. That example is like this. Okay, so the same class I took it. Okay, generic class. But here, what I did, here I have created without passing the type information. I am not passing type argument here. I'm not passing type argument here. So we for both of these things, I have not passed type argument here. Okay. Can anyone figure out what is the error here? What is the runtime error we will get here? Can anyone notice and tell me what is the runtime error we get here? We have discussed this in our previous class. Can anyone notice and tell me what is the error? We are not noticing any error in compile time. Okay, while compiling we don't get any error, but there is a runtime error here. We have discussed this runtime error yesterday in our previous session. Okay, can anyone notice and tell me what is the error? It is simple. Yesterday we discussed about it. Here what am I doing? I am creating AD object with integer and CD object with a string. Okay, AD is pointing to integer. Okay, and CD is pointing to string. Okay, now I am assigning a string object to an integer object and trying to get integer. Okay, trying to get integer. That is when you get your runtime error. So types ST are what was the main advantage of using the generics? Runtime exceptions. Runtime exceptions will become compile time errors. Right? Now with this raw type with respect to generic types, okay? With this raw type, that advantage is lost. Okay, that advantage is lost. That is why we should generics we should use with the type arguments, not without type arguments. This is provided only as convenience for us to migrate from JDK pre-JDK 5 versions. Okay, pre-JDK 5 versions to JDK 5 version plus. Okay, JDK 5 version and upper versions. Okay. Okay. So we have a couple of topics, and we will finish that after the finishing that those two couple of topics. Okay. So we have, let us forget about this. We have non-generic superclass. Okay, and we have generic subclass. So that is possible. The other way, try the other way. Generic generic superclass and non-generic subclass. Okay, try it that way. But I think you can find out with respect to this one. What is that interface? Generic interface and non-generic class, right? With that itself, we can infer what could be the reason, and what could be, whether it is possible with non-generic subclass and generic superclass. Okay. So here what we are taking, non-generic superclass, generic subclass. So that is possible. You can have, but what is the thing? Like you have generic class which takes one integer. Okay. And subclass, anyway, we have to pass that integer to your superclass in order to create superclass object. Okay, in order to create superclass object. So this is how you can do it, or this way you can do it. Here, integer is passed here, and this object we have assigned it to this object, and we are getting the respective object type. Okay, that is also possible. This way, just to create superclass object. This is just to create superclass object, and this one creates both. Here we are passing the integer type to super. We know how to call superclass constructor using super keyword. Okay, so that is one example. So what else do we have? So this is generic class hierarchy. Okay. So one more thing is that this is our generic class. This one is generic subclass. Here, if you notice, generic subclass is also generic. Superclass is also generic. Okay. Subclass 2 takes 2 generic types. Superclass has only one generic type. Okay. Oh, here I have mentioned. Okay, here this is not allowing. Okay, as we discussed with the interfaces, here we cannot have a generic class, non-generic subclass which extends generic class. Okay, as we discussed with our interfaces and classes. Okay, it has to be any class that either extends generic class or generic interface must be generic class. Okay, that is important. So here, if you have only one parameter, if a generic class takes only one type parameter, it does not mean that subclass can have has to have only subclass has to have only type only one type information. Okay, here this particular subclass is taking two type parameters, whereas generic class takes only one type parameter. Okay, this is also possible. So what you have to do is, whatever the parameter that superclass takes, just pass it in your super constructor call, and then do the necessary thing, other thing, whatever you want to do, you can do that one. Okay. But important point to remember here, again, non-generic classes cannot implement or extend generic interface or generic class. Okay, so only generic classes can implement or extend generic types. Okay, let us try to run this program. This is generic hierarchy class. Okay, here you can see we are displaying the information. That's it. Okay, so generic subclass 2 that takes two parameters, type parameters. Okay, that's why we are passing two arguments here, two things here, and we are printing the type object. That is what is getting printed in our output. Okay, these are the output. Okay, you can analyze these things when we share this code. Okay, one last topic is there. So some okay, I don't have that example. I thought this one is possible, not possible. Okay, so runtime type comparison. You just go to this one. This is an instance of operator, that is runtime type information operator. You can compare one class. Okay, say for example you have class A, and you can say an object. You can compare this with an object to say like instance. Is it an instance of A class? Okay, A class or something like that. You can use that instance of operators with the objects to confirm that a particular object is of type particular class. Okay, so instance of operators, try this thing, and the method overriding in generic class, it is possible. Okay, so I don't have an example for those things. If you want, I can give it in next class. Okay, I can explain it in next class. Okay, I don't have an example right now. So generic restrictions for type parameters, whatever the type parameter that you pass, right, to T, you will have a type object, right? So you cannot create an instance of this particular type parameter itself inside your generics. Okay, inside your generics, and these are the two restrictions for your arrays. Okay, okay. I think that is the end of generics. If you have any questions or doubts, please let me know. Otherwise, we can wind this call. You can send your doubts or questions to Intuition. javatraining@gmail.com. So I have sent an email to everyone with this particular Gmail ID only. You can send an email with all your questions. We'll try to respond. I'll try to respond to your questions. Okay. Okay. Yeah. If you have any questions, we can try to answer. I mean, we can. I'll try to clarify those questions. Otherwise, we can wind up this call. Okay. Yeah. Thanks, everyone. Thanks for attending this session. So if you have any doubts, please let me know or send me an email. Okay. I'll try to respond to that email. Yeah. Thanks, everyone.